Hello, I'm JW. This time I'm going to be installing a hard drive in the computer, and this is because there's simply not enough space left. Here's a quick view of the current storage situation, and as you can see, pretty much filled up there. And it's not going to be practical to delete a whole load of stuff, so of course the only option is to install another hard drive. Now, this particular computer is the one that I use pretty much every day, and this machine was actually assembled in 2010, so it's a fairly old machine. Nevertheless, it still works perfectly well and does the job it was intended for, so this is just adding extra storage to that. Now, I've already removed the computer from the floor and disconnected all the wiring. There was quite a lot of dust in here because, so unfortunately, it sits on the floor, so a fair amount of dust does get in there despite having filters and things on there. And obviously the things you're going to need for this are the hard drive itself, so here it is, this in the foil packet here. And the other thing we're going to need, of course, is a cable. This is a SATA cable, and also it just connects the one end in the drive there and the other inside the machine there. And of course the drive also needs power. We also have enough power connectors here which are spare, so we'll just use one of those. Now, so this is a fairly large case, and it's quite dusty inside, so I'll probably just clean out some of the dust a bit later on. And it already has a number of hard drives in the bottom here, and this obviously is the power supply here, and we've also got a drive here, one in there, and another two over here, so already 4 in there. This is going to be number 5. And on the board here we can see the existing starter cables, these red things, just go into the various locations. Here's a look inside the bottom of the case. So we've got the existing drives here, as you can see that's the power supply there, and we're just going to put the new hard drive in this space here, as that's the most convenient one for that. This power cable here will of course reach to that no problem. In theory, put it over there, but then we're going to have to rearrange half the power cabling and things, so just easier to stick it over this side. Here's a look in the upper part of the case, is the motherboard in the back there, and these cables here are where the SATA things connect. Now, we've actually got 6 of these currently in use. However, of course this is a problem because there's no spare, but not a problem in fact, because one of these actually goes to a port on the outside, one of those eSATA things. Now, I've never used that, and eSATA as a whole is pretty much obsolete. The idea was originally that you could plug a hard drive in externally into that connector and it would operate at the same speed as everything else. But unfortunately, as soon as that was introduced, USB 3 came along, and of course that made eSATA pretty much obsolete from the start. So I've never used it, we're never going to use it. So what we're going to do is just unplug the one that goes to that one, and of course just connect our new hard drive to that. So I've got here's the graphics card there on the side. It doesn't have a fan, it's a fanless style. And the 2 processors here, these are actually Xeon processors. I think they're E5505 or something like that. Again, they're pretty old because this machine was assembled in 2010, so that's over 8 years ago. And motherboard underneath is a Super Micro. It's actually designed for a server use, but nevertheless does the job here. And that's pretty much all we've got there, so we're just going to remove one of these cables once I've found out which one it is, and then we'll just put our new cable from there down to the drive underneath. Now, the cable for the eSATA was actually the one there on the right hand side, so just undone that and put in the new cable here. These only fit one way round, so can't really get it wrong. This one has a little release clip on it, the other ones apparently did not, so no real mystery there. So one end plugs in there, then the other one goes into the drive. So of course we want to thread this through the hole in the actual board here, because if we put it there, then obviously the case lid won't actually fit. So we'll do is just thread that through there, and that will come out underneath. Now, in terms of the actual drive mounting, this one doesn't actually got any screws or tools or anything. It has these plastic pieces here which just remove from there. So essentially 2 of them. One goes on each side of the drive, and then it just basically shoves in there in the slot. This is the drive we're going to be fitting. This is a Seagate Barracuda, and the capacity is 6 terabytes. And it's in the standard size 3.5 inch casing. That's the back there, and not much to say about that. Just got the holes in the side where screws could go, although so these things we've got will just line up with those holes anyway. And only main thing here is to put it first of all the right way up with the lid on the top, and of course so the connectors here are actually on this side, so of course we can plug the things into them. Now, in terms of these plastic jobs, the only thing there is to get those 3 pegs lined up with the 3 holes, and then the little tab there just goes underneath as a kind of support. So that's pretty much it fitted. and then of course on the other side it's going to be pretty much the same deal, and then this whole assembly will just slide in there. Now I'm just going to remove the connector from the one above so we can slide it in. And then that's installed, so no messing up with screwdrivers or any of that faff required. So I just need to put the connectors on the back here, and I got the power here, so it's just going to be using that spare connector we had on this already. And then the SATA cable of course goes on to the appropriate place, so just bend this before we put it in there so we can get them both connected on. So that's the power there, and then again the SATA one just goes underneath there, and again they only fit one way, as do the power connectors, so again not any particular mystery about connecting that. So that's connected up there, and that is pretty much it in terms of the actual hardware installation. All that's left now just to clean out some of the rest of this dust and things in here, and then we'll put it back together and switch it on. So I've cleaned away the majority of the worst parts of the dust. I'm not going to go to every extreme and clean every particle off because that's not going to achieve anything. Now, two fails on this board, even though it works perfectly well. This fan here had to be added in later because the thing underneath it tended to get extremely hot. It's either the south bridge or the north bridge or one of those bridge type things. There is a heatsink there, but very small, hence that fan is at that weird jaunty angle. And the other fail with it is that these heatsink things here for the processors actually slightly overlap in the middle. Not terrible design, but obviously it would be better if they didn't, but they're sort of a mesh grating type thing anyway, so they do sort of just slightly overlap in the middle. But other than that, nothing inherently wrong with it, and it still works fine despite it being assembled 8 odd years ago. So that's it back together, or all the stuff plugged back in. So let's turn on, and also now we have to configure the thing as we need. So we've got all of our devices listed there, so basically it's 4 standard hard drives, 1 solid state which just shows on the hard disk, and of course the CD-ROM which was there anyway, so everything appears to have been detected there. So these are pretty much automatic anyway, so not a problem with that. So that's that ST6000 job we just put in, 6 terabytes, which is what we want, and all the other stuff is pretty much standard business anyway. And although you can allegedly configure this stuff, we're just going to leave everything at auto and whatever, because that's what we do. That's one of the others, that's one of the original ones. That's only a 1 terabyte thing, which although these days is quite small, when this thing was assembled in 2010 that was actually quite a large deal, and so it had 2 of those as original. That's the, or one of the ones that was put in later. That was probably about 4 or 5 years ago or something. That's a 3 terabyte drive, and that's the other original one, the 1 terabyte, and of course that's the solid state job, which again is original to 2010. That's only 80 gigabytes, but again it's only for the operating system mainly, so it doesn't actually matter. The main point is it's solid state, so of course massively faster than a rotating drive. And the one we actually put in, which is this thing here, it's actually not a particularly high speed item. It's only a 5400 RPM thing, but the point of it is for storage capacity. Actual speed isn't particularly a concern with that. It's purely for storage purposes, so whether it's a bit slow or not doesn't really matter. So anyway, that all seems to be there as we expect, so that's fine. So we'll just come out of there, and say all the rest is retained there. That's basically what we've got on the system there. So it's the Xeon 5504s, 2 of them, and they're 4 core processors, so it's obviously 2 processors with 8 cores in total. and there's 12 gigabytes of RAM installed, and the motherboard is a Supermicro X8 DAL, and it says there it's from 2010. Now this is the boot list here, which somehow got all tangled up. Now we don't want to be booting from the other drive, so we'll just set all of these others to disabled, because they're not boot drives and they never will be. All we want is that solid state jobby on the top. CD drive is still there, so that's fine. Not that that gets used much these days, because of course software in general doesn't actually get supplied on DVDs or CDs anymore. And we'll just check the yeah, that's fine. So obviously boot from the hard drive first. So certainly has been recognised there. So we'll just get out of there, and obviously we need to actually save those. So that is what we shall do. So now I just need to load up, and hopefully Windows will still work. And obviously we need to configure the drive, else it's not going to be partitioned or whatever else. So once Windows has started, we can do that. Oh yes, I forgot about that. Yes, the last time it was turned off, there was some stupid updates had to be installed, so no doubt we're going to have to wait for all that bother as well. What a waste of time. Unfortunately these days you can't disable the updates, and probably shouldn't even if you could anyway, but it does seem that every couple of days there's some stupid update has to be installed, each one of which could potentially break things, and quite often does. So we'll just sign in there and see what we can do. Now it is obviously working, and this has twin screens obviously, as you can see there, so the point of that is that it's all one, so you can obviously just move things from one screen to the other as required. Now the colour might look slightly different where the camera angle is because of the angle of the screen. These are actually the original screens from 2010. They're not LED backlit, they're actually fluorescent backlit, hence they'll take a while to get going. And now it's time for thousands of modifications. Our mouse is ready to go. Well, that's handy because we're already using it. What a stupid waste of time that is. What's all this garbage? They're setting up a keyboard. Yes, well I suppose we'd probably plug them in the wrong or different sockets, but whatever, like we care. But obviously working because we're already using it. Now this is the disk management thing here, and we can see our new drive here is this disk 2. Now I've already selected the type here, which you can see here, which is partition style is GPT. The other option is that master boot record, which is for basically ancient versions of Windows from many years ago. So obviously we're going to use the more up-to-date one because we don't care about compatibility with older versions. So GPT is what we're using, and we can see that the capacity is that kind of 6 terabytes in a not really kind of way, but nevertheless it's what we would expect. And all the other stuff is pretty much standard gubbins on there, and that's basically the model number at the top there for anybody who actually cares. Now see here, this is actually all of the discs we have, so the new one we've added is disk 2, and that's that one in the middle there with the black line, obviously unallocated at the moment. The others here, DVD-ROM at the bottom. Disk 4 is actually the boot drive, which is that solid state 80 gigabyte one. That's an original from 2010. Disk 3 is also original, that's a 1 terabyte. That's currently divided up into 2, so it's H and I. They were equal originally, but it's been changed subsequently to make that one smaller and that one larger. Disk 1 again is original, the 1 terabyte job, and that's in again 2 partitions, J and K, and those are around half a terabyte each. And then disk O is one which was added a few years after that. It was probably about sort of 4 years ago or something, and that's a 3 terabyte job, and that's actually divided up into 3 equal sizes, so roughly 1 terabyte on each, L, M and N. And then of course disk 2 is going to be partitioning now, so just go into new simple volume there, and it's a question of selecting the appropriate size that we would want. Now we don't want the entire thing to be a single partition because I don't want a 6 terabyte partition, and that's completely pointless anyway, so what we're going to do is type in the appropriate size here. So we're going to go with this one for 1907716, which should be a third of the total. How bizarre, you can actually have a disk partition as small as 8 megabytes, even with things these days. So assign the following live letter. Well, I don't think we're going to go for E somehow, because the whole point of these not using that is that when you plug in external flash drives and things, they actually fill in the space between C and H, which is why there aren't any in that sort of space there. The DVD is D, of course, but E, F and G, as you see, don't exist, which is why that was done. So we're not going to have that. We're going to go above whatever we've got. So N was the last one, so we're going to go for letter O. In fact, these other options are mount in the following folder, which we're not doing. Something stolen from Unix, presumably. And do not assign a drive letter or path. Well, that's a big waste of time, isn't it? Now we're going to format it with NTFS, obviously, and we're going to use the default settings. I'll do a quick format for now, but that will do. We'll change the volume labels later as well, and we're not going to be using compression, so moving on. So let's just get on with that. Right, well there it is. It's called new volume O. Well, that's delightful, so get rid of that. Now we need to do the rest, of course, because there's a big chunk of unallocated here, so we'll do pretty much the same again, and fill in the sizes that we require. For this one we go for the same size we just used before, which is 1907716. So basically 2 terabytes, or the equivalent of. And again, we're going to be assigning not letter E, how pathetic, and actually going to be using the next one up in the alphabet, which is what we have O before. So this is going to be P, presumably. Yes, that's the one. Unbelievable, forget the actual alphabet, and we'll use default settings as before, so we'll just hash that in there. So now I have a P, which is nice, and let's get rid of that. And then the remaining part at the end is basically the same size as it's, well, 0.01, but pretty much the same deal, so we'll just stick a volume on that as well. Now, size for this, we could use the whole thing, I suppose. That will give us 3 of 2 terabytes each. That seems sensible, so we'll do that. And the next one is going to be Q, of course, so there we go. So yeah, we just use default settings, no surprise there. And there's Q. So that's what we ended up with, and all partitioned up and checked and whatever else. And I've renamed the new ones with the same scheme as the others. So OP and Q are now storage 4A, 4B, and 4C, and these are not quite right. I mean, the original idea was that the number indicated the physical device, and then the letter just indicated a part of that. And this is useful, particularly if you're going to be copying stuff from one drive to another, as in video editing and the like, because it's not desirable to have the primary material on one drive and then be trying to write the actual outgoing file to the exact same drive as well. As you can imagine, that causes something of a clog, or at least it does on this system. Other systems, of course, may be different. But unfortunately it didn't quite work out, because if you look at the top, disk O at the top is actually the one with the number 1 in the names, disk 1 is number 2, disk 2 is actually 4 because that's the one we just added, disk 3 is actually disk 0, and disk 4 is disk 3. So that doesn't quite work, but the point is that on each one they can sit within it. So if it's 2, 2A and 2B are on the same physical device, and of course 1 is the same, and so on. And I'm not going to change them now because that could lead to trouble and problems which we don't want to actually invite. So that's installing a hard drive, not a particularly difficult procedure, as long as you make sure you've got the actual cables available, as in the data cable there, and of course the power connection as well. And I'll tell you, that one had those plastic rails, which are quite easy to use, or if not it would have been screws into those little things on the side. And that's all done now, apart from obviously shoveling all of that massive amount of data around into more appropriate places, because of course the whole point of putting it in was to actually use it. And no, we don't have any kind of RAID set up on this thing. RAID is generally pointless for a single machine like that. It either achieves a significant reduction in storage space, and in usual cases a significant reduction in reliability as well. And for anyone who thinks that RAID is some kind of magic saviour that protects your data forever, then unfortunately you are wrong, because if you say have a RAID setup where you've got, say, 2 drives mirrored, and you put 2 drives in there, if one fails, then yes, it's all on the other drive, but unfortunately if you put 2 drives in at the same time, new from the manufacturer, the chances are they're going to both fail around the same time anyway, so very likely that if one fails, the other one fails shortly afterwards. So certainly not some kind of wonderful panacea to solve all data storage problems. And a fair number of the other RAID setups of which there's quite a lot. You can go look them up on Wikipedia or something. A fair number of those also have the same problem, so that even if you've got a system where, say, you've got 5 drives and one of them can fail, the problem is that whilst you're rebuilding that drive, it puts all the strain on the others because it's got to read in the data from all 4. And of course that's a very time when one of those others, which is going to be the same age and manufacturer as the other one, is going to fail as well. So fairly likely that it's a big disaster anyway. Of course the answer to data is to make backups and store them far away, preferably not even in the same building. But anyway, that's it for this time, and until next time, thanks for watching.